Hello my friends, this is Miss Alonso via video. I'm going to be doing the lesson through this video, so I hope you are able to follow along. You're supposed to have an X-ray marker, a pencil, the activity sheet that Miss Navarro handed you, but we're not going to focus on this right now. We'll get to this in a little bit, and the fraction circles, as well as I didn't forget, but before I forget, I should say a post-it. Everybody should have a post-it, a pencil, X-ray marker, and fraction circles, and the activity sheet. I did not mention this, but if you can, I hope you can take out a red pen or red pencil or red color. Just a red utensil, that's it, okay? So, before we start, I believe you watched a video, a part of a video where the lady explained the objective, but I'm going to read it to you again. It says, you are going to be able to illustrate a measure of an angle as a part of a circle whose center is at the vertex of the angle that is cut out by the rays of the angle. Again, that is technically referring to seeing a circle, and you're going to illustrate the measure of an angle as part of a circle whose center is at the vertex. So this is the center. My circle's, my circle is not perfect. Sorry, my phone was about to die. Or at the center, but it's saying this, the vertex, remember, vertex is pretty much where two rays meet the vertex, right? Oh, you can't even see that. So vertex is where two rays meet, okay? So remember, a ray has an endpoint and an infinite line that way. And if I add another one, I get an angle. So it's saying that you're going to be able to pretty much measure an angle inside the circle. And that's what we're going to get into. If you didn't watch the video, it's okay, but this is what we're going to do. You're going to be able to see a circle and measure the angles within a circle, and we will get there. Okay, but before we get there, I want us to quickly, or not quickly, but we are going to get our post-it. So everybody should have a post-it. Okay, so everybody should have their post-it. I want you to look at this post-it. Making sure sorry guys, this is the first time I'm using my phone to record a lesson, so bear with me and the technical issues I'm going to have. So we have a square, right? A square. I want us to think about what we know about a square, what attributes we know about the square. I want us to classify it. Let me try to get a different poster because you really can't see the color. Yeah, you can see it pink. Okay, so what do we know? I'm getting a different poster because I like the color better. About a square. So I want you to take about 10 seconds to tell your partner what you know about a square. And even though I can't hear you, Miss Navarro can hear you, and I hope that you are talking. So I'm giving you a couple of seconds to discuss what we know about a square. Okay, in my morning class, let's have Leo share something we know about a square. And I'm being serious, and I know you're probably laughing, but I'm being very serious. Let's have Leo share what we know. I hope you said that it has four right angles. If you didn't, then that's one attribute. I'm just kidding. I'm not going to call out names. It has 4 sides, which classifies it as a quadrilateral. It has 4 equal sides, right? Which classifies it as a rhombus. It has 2 sets of parallel lines. Remember, we look at the opposite, which classifies it as a parallelogram. And then the 4 right angles classify it as a rectangle. So we know all the attributes about a square, the names of a square. So now what we're going to do is we are going to get this square, and I want you to also, since y'all talked about symmetry yesterday, we know that it has 4 lines of symmetry, right? Well, yeah, 4 lines of symmetry. Remember, symmetry is congruent. If you fold it in half, it should be a reflection of the other side. But we'll get to that later. Anyways, I want you to grab your square, and I want you to, you're going to rip off the edge, the 4 edges of the square in a rounded way, like circular way, and I'll show you. So you're going to take it out, rip it off like this. Okay? Doesn't have to be perfect, because look at mine. Not perfect. I just want you to try it. Your best. You're ripping off the circle, and I hope we're all following along. Evan, I hope you're following along. Leo and Anthony, I know y'all are sitting next to each other, but I hope you're following along. Okay, so this you don't need. You're going to put it to the side. I want you to grab your 4 pieces, okay? And I want you to tell me what you notice about each 4 piece. What do you notice about each one? If you see, and if you said right angles, you are correct. So I want you to go ahead and put the 4 pieces. One side is a little bit too long, but that's okay, because I'll make it work. 4 pieces together, like this. Here, let me rip off this little side. Okay? Doesn't have to be perfectly all in there, but if I put them together, these 4 right angles, what do we see? What do we get? You should be following along. You should have the 4 pieces on your desk, and you should have your expo marker, okay? Because we're going to draw a circle around these 4 pieces. Because if you haven't noticed, I hope you're following along, these 4 shapes create a circle. Now, it's not going to be perfect. For sure, mine won't. But I want you to just try your best, okay? So a circle, right? Draw a circle around. Now, what do I mean about angles within a circle? I want you to think about that question. Ask yourself, what do I mean? Well, let's think about it. I want you to take one of the pieces off, put it to the side. If I take one away, what do you notice about right here? I want you to draw a line, and if you said 90-degree angles, you are correct. 90-degree angles, right? Right here, this piece. So I took one piece away, and I am showing a right angle in a circle. Now, what if I take, so I'm going to write 90 degrees. Remember, degree sign is the circle. A degree is what we measure angles with. And each degree is 1/360th of a rotation around the circle. So degrees, this is called a degree, is what we measure angles with, okay? Well, anyways, let's get back to the lesson. So if I take 2 pieces away, if I take 2, I see that I have another right angle, right? And I know it's not perfect, but bear with me. And I'm going to write 90 degrees. I have another 90 degrees. And if I draw it at the bottom, and I want you to draw this with me, what do I know about 90 plus 90? I have 2 right angles, and then I have this straight angle right here. And I'm going to model it for you at the bottom, right? You see, right here, right here. Well, if I add up 90 plus 90 is 180. So I know that this angle right here, this straight angle, is 180. So again, one corner is 90 degrees, or one part of a circle is 90 degrees. If I took the other one, I have 90 degrees, which now created a line of 180 degrees. I hope you are following. Don't worry, we are going to work little by little. So again, half of a circle is 180 degrees. Half of the circle. Now, if I take the third one away, I see that I have another right angle, right? I have another right angle. And then obviously a circle is perfectly circled, but this one is just illustration. I have what? If 90 plus 90 is 180 degrees, what do you think 90 plus 90 plus 90? What do you think the measure of this angle is? So if I took this away, this right here, okay? And I'm going to try to erase. Oh, you know what? No, don't erase. I want you to leave it. What do you think this angle right here is? Well, let's see. I have 3 90-degree angles. I can either do 90 plus 90 plus 90, or, well, let's do 90 plus 90 plus 90. 90 plus 90 plus 90. 90 plus 90 plus 90 is 270 degrees. You might be wondering, how did you get 270, Ms. Alonso? Well, I know that 9 times 3 is 27. And if I follow the rules of boxing and balancing my zeros, I get 270 degrees. So right now, this angle right here, this one, is showing 270 degrees. Now, if I took the last one away, I still have this 90-degree angles, right? Well, if 90 plus 90 plus 90 equals 270, how can I determine the whole angle of a circle? The whole angle of the circle. From this end all the way around. Think about it. We're going to add, and if you said we're going to add 90 plus 90 plus 90 plus 90, you are correct. So let's try that. 90 plus 90 . Well, if 90 3 times is 270. Well, I'm going to use my rules of multiplication because this is technically repeated addition. Well, 9 times 4 is 36. And if I do the box and balancing my zeros, I know I get 360. So in other words, the full measurement of a circle is 360 degrees. Okay? 360 degrees. So all the way around is 360 degrees. Remember, we are cutting the vertex. The vertex would be in the middle, right here. And I can cut out the angle by using my rays. And we're going to explore this a little bit more. So I just want you to know that a whole circle is 360 degrees. And you just saw why. So we just finished talking about why a circle is 360 degrees. We have to be thankful for people who discovered this and who pretty much guided us in understanding mathematical concept. Now, one thing I want you to pay attention to, and you don't have this, but I want you to look up here. I want you to, we know that a circle is 360 degrees, right? Because half of a circle is 180 degrees, and it's this way. It's right here, 0. Half a circle is 180. And then we know that there's 90 degrees.